All right, so these are going to be the notes for expanding logarithms. So let me erase this here. So first we're going to recall the properties from the exponent rules. So the first one says, recall the properties of exponents. The first one is the product property. So if you recall, for this one here, when we have a to the n times a to the m, it's going to be a to the n plus m. You add the exponents together. Okay, so how does that relate to the properties of logarithms? Well, when you have a log base b and you have m times n, since they're being multiplied, we're going to add. So here we're going to write two logarithms. So log base b of m plus, and now we have to have the same log base b of n. Okay, so notice we separated it by, or we expanded it by addition. All right, and next, the quotient rule says when we are dividing bases that are the same, what do we do to the exponents? Well, this time we subtract them. So a to the n minus m. So over here, when we have a logarithm base b and inside our argument, it is being divided, we're going to expand them by subtraction. So we have log base b of m, because that's on the top, and on the bottom we subtract it. So log base b of n. So notice the top part is comes first, and we subtract log base b of the bottom part. And then last, we have the power property. The power property says when you have a base with an exponent raised to another power, what we actually do here is we multiply those two together. So a to the n times n. Now over here, to make that property work, what we're going to do is we're going to take this n right here, and we're going to move it to the front. So that's going to become n times log base b of m. All right. Now, just for reference, on the left side, this is called condensing, which we'll do tomorrow. But right now, we're going to focus on this part, which is expanding the logarithm. Okay. So let me go ahead and erase this real quick. So I'm going to have that there. And that's how they are related. Okay. So again, refresh or recall. If you are log base b and inside they're multiplying, you expand them by addition. So log base b of m plus log base c of n. And when you are dividing inside the argument, you're going to expand them by subtraction. Notice there's a subtraction on the second one. And then last, when you have power to a power, you bring the exponent to the front and multiply it to the log. Okay, so let's go ahead and apply these three properties. Those are the only three properties we need. So for the first one, we have log base 4 of 7 times 5. That's going to be called the product property. So it wants us to expand. And the way we're going to expand this is through addition. So we're going to start with log base 4 of 7 plus log base 4 of 5. And once we do this here, we do double check to make sure that we can't do anything extra, like simplify something. In this case, we can't. So this is my final answer. All right, for the next one, we have log of 10x. So again, they are being multiplied. So we're going to expand it by addition. So we have log of 10 plus log of x. Now, hopefully recall that when you don't have a base, the base is a 10 here. And right here, if you recall, this log base 10 of 10, these are inverses. So they actually cancel out. And that's going to simplify log base 10 of 10 to 1. And then plus log base 10 of x. And recall, if we don't put the base, then it's called a common logarithm. We assume it to be 10. All right, the next one is a little bit different here. It says log base 2 of 72. Again, they want us to expand it using the product property. So in this case, you would just separate it into two numbers that multiply to 72. So in this case, I could use 9 and 8. I can use 2 and 36 and so on. So let me kind of show you what I would do. I would use 8 and 9. So if I said log base 2 of 8 times 9, then we could break this apart by addition. This would be log base 2 of 8 plus log base 2 of 9. Okay. Now, this answer is fine, but there is actually a step further you can go on this. If you recall that 8 is going to be raised to the 8 is 2 cubed. And then over here, 9, we can't really do anything to it, so we're going to leave it alone because 3 squared does not affect anything. But what I'm showing you this is because if the bases are the same and we cross these out, it actually becomes 3 plus log base 2 of 9. Okay, so that's the simplified version right here. But just using the property, we have log base 2 of 8 plus log base 2 of 9. Eventually, we will get to here, but right now, that's what we're looking for, is to make sure you can expand them. Okay, so for this number 4 one here, again, we're expanding. So you're going to have to recall a little bit of prior knowledge on this one. If you recall, x squared minus 4, if we were to factor that out, that's a difference of 2 squares. So I have log of, and this would be x plus 2 and x minus 2. So these are being multiplied, and I can expand them through addition. So, oh, and the base is 5. Sorry, I forgot that base there. Okay, so here it would be log base 5 of x plus 2 plus log base 5 of x minus 2. And in this case, it wouldn't matter if you did the x minus 2 or x plus 2 first, since you are adding. Okay, so that's what I think we're looking for on that one. So that is the product property when you're doing expanding logarithms. The next one, it says to expand using the quotient property. So when we're doing this property here, so log base 7 of 19 over x, so we're going to subtract them. Again, when we're expanding, we have multiple logs for this one. So we're going to start with log base 7. And the number on top goes first, which is 19. And then we subtract anything that's on the bottom. So in this case, there's an x, so it's going to be minus log base 7 of x. So the top stays positive if it is, and the bottom, you subtract it. Now, if there's multiple things on the bottom, then you would subtract them all. Okay, so this one's a little bit different. Log base 3 of 8. It wants me to use the quotient property, but I'm assuming here you have to figure out two numbers that divide in to give you 8. So in this case, I'm going to rewrite it as log base 3 of, unless we know that 16 divided by 2 is 8. So when we expand these, the top part is going to be log base 3 of 16. And here we subtract the bottom, log base 3 of 2. So that's how you expand that there. For number 7, same thing. Let's see. So we have ln. Okay, so ln log, you're still going to expand it. On the top is going to be ln of 3. And we're going to subtract the bottom part, which becomes ln of 4. And then for number 8, we have log of x minus 7 over x plus 1. Now, one thing I want to point out, notice it's only one log. There shouldn't be multiple logs with this problem, okay? So if it's multiple logs, then you can't actually use the properties. If you go back to the properties, it always starts with one log, and then it expands into multiple ones for the most part. So here we have log of x minus 7 divided by x plus 1. So again, we're going to start with the top one, log of x minus 7. Then we're going to subtract log of x plus 1. And we can't go any further, so there's our expanded form. Now the last one is the power property. This is where you take the exponent and you move it to the front and you multiply it to that log. So for this first one here, we have an exponent of 4. We're going to move that to the front and multiply it to the log. So my answer here would be 4 times log base 5 of 7. And I can't simplify any further, so this is my final answer. For number 10, we talked about this in class, that the square root is equivalent to, as an exponent, 1/2 power. So here we can say ln of x, let me go back on that here. Ln of x to the 1/2 power. So that means this exponent right here, we're going to move it to the front. And that's going to give us 1/2 times ln of x. All right, so for the next one, we only have an x here. So we're going to take that x, we're going to move it to the front and multiply it. So x times log base 2 of 5. And then for this last one here, again, here we have a cube root. So ln of 2x plus 1. And if it was square root, it was 1/2 power. So if it's a cube root, it's going to be the 1/3 power. All right. And just like before, we're going to take this exponent and we're going to move it to the front and multiply it to the log. So in this case, it would be 1/3 times ln of 2x plus 1. And I can't simplify any further because there's no way to reduce anything. Okay. So those are the three properties all together there. So we expanded by product properties, by addition, quotient property we subtracted, and power property we multiplied to the front of the log. All right, so now let's go ahead and take a look right here at number 13. It says, use logarithmic properties to expand the following as much as possible. Okay, so whenever I do these types of problems, the first thing I do is I expand them through addition. So the product property. So right here, we see they're being multiplied. So I'm going to start by I'm going to separate them into two different logs using a plus sign. So log base b of x squared plus log base b. Now the square root of y, I'm going to automatically convert that to the 1/2 power because we know that's what it equals. Okay, so that's our first step in expanding. We expanded it by addition. The second thing I'm going to do, I see these exponents right here. And hopefully you recall the exponents move to the front when you're expanding. All right, so now we have, for the first one, we have 2 times log base b of x plus, now the 1/2 goes in front of log, 1/2 times log base b of y. And then before we say this is our final answer, we look to see if we can simplify anything else, and nothing reduces. So this is going to be our final answer. All right, let's take a look at number 14. So 14, again, this one's a little bit different here. I usually look for that multiplication, but since I see this little exponent right here, automatically, since we have to take care of that first, we're going to move that to the front of the log. So it's going to be 2 times log base 2 of 15 times x cubed. Okay. Now this one's a little bit different, so do pay attention here. When I expand this, okay, because I have a multiplication, so I'm expanding it by addition. So the first one's going to be 2 times log base 2 of 15 plus, now here's the thing. This power of 2 wasn't just to the 15, it was also to x cubed. So when I rewrite the second one, it's not going to be log base 2, it's going to be 2 times log base 2 of x to the 3rd power. Okay, so that 2, notice, went in front of both logs, and that's what needs to happen. Last thing, we notice that we have a power of 3, and for this one, we know it goes to the front, and it's going to multiply to the 2. So I'm going to show you that step. So we have 2 times log base 2 of 15. I can't do anything to simplify this. Plus, when we move the 3 to the front, it becomes 3 times 2 times log base 2 of x. And my last step, 2 times log base 2 of 15. And here we're going to multiply that, 3 times 2, which is going to be 6. So plus 6 times log base 2 of x. And now it is fully expanded. Okay. And again, I didn't see any places where I could reduce, so this is my final answer there. All right, for number 15. So this one's a little bit different because we have a division here, right? So I'll tell you this right now, whenever I do logs and I'm dividing it, anything on the top is going to be a positive, anything on the bottom is going to be a minus. Okay, so let me show you what that means. So on the top, we have log base 6 of x to the, now cube root, if you recall, is the 1/3 power. So log base 6 of x to the 1/3 power. Now, we have two things on the bottom. They're being multiplied, but again, anything on the bottom, I'm going to subtract. So for my first one, I'm going to expand it while I separate them. So I have minus log base 6 of 36 minus log base 6 of y to the 4th. Okay. And if you're curious about that, if you wanted to expand it by addition, then this would become a plus sign, but then you have parentheses around here, right? So the parentheses, when you distribute this, becomes negative, and the plus sign also becomes a negative as well. So that's why I kind of just, anything on the bottom, I subtract. Anything on the top, you'll see me multiply. Okay, so again, just to recap, log base 6 of 36 was on the bottom, so that's why it's a minus sign. then log base 6 of y to the 4th, that's on the bottom, that's why that's another not minus sign. Okay, next thing I'm going to do, I'm going to start with my exponents. I'm going to move this to the front. This one we're going to actually change it in a second. And this 4, I'm going to move it to the front. So let's start with that. So we bring the 1/2 power in front. So that's going to be 1/2 times log base 6 of x. And this one actually is simplified as far as I can go for that first part. Minus log base 6. So when I look at this here, 36 is the same thing as 6 squared. Now, why did I convert it to 6 squared? Well, I created common bases. And what that happens, what it allows me to do is these right here are going to cancel out, and that's going to leave me with just the 2. Minus, now we're going to bring the 4 in front, 4 times log base 6 of y. So last but not least, when I write my final answer, the first one is simplified, 1/2 times log base 6 of x. This one becomes minus 2, right? Because the log base 6 and the 6 canceled, and the only thing that's left is that 2. Minus 4 times log base 6 of y. And that is my final answer there. All right, moving on to number 16. And let me just verify. Yeah, that's going to be our last problem here. So let's take a look at number 16. Again, anything on the top is addition. Anything on the bottom will be subtraction. So there's no base here, so we know it's a common logarithm. Base is 10. I'm not going to write it in there. But again, these top two are being multiplied. So the first one's going to be log of x to the 3rd, or x cubed. Since they're being multiplied on the top, I said when you separate them, it's going to be addition. So log plus log of y squared. Now on the bottom is the square root of z. So anything on the bottom, we're going to subtract. We expand it and subtract it. So here, minus log of, and again, that 1/2 power because of the square root. Last but not least, we're going to move our exponents to the front. So the first one moves to the front. So 3 times log of x. And I look at that, I can't simplify further. Now we're going to move the 2 to the front. So that's going to be plus 2 times log of y. And for the last one, we're going to move that 1/2 power to the front. So minus 1/2 times log of z. And again, I can't go any further, so that is fully condensed. All right, and that's going to complete the notes.